Hello, everybody. I want to welcome you to our December chapter meeting, which is a joint meeting between Minnesota ISSA and CSA Minnesota. Very excited for our speakers today. Just a couple announcements here before we begin. We did want to start, just since there's audiences from both chapters on, we did want to start and kind of just give a brief background on both organizations. So I'll start with Minnesota ISSA. We're a general organization, we kind of cover all the security domains, and we focus, we're based in the Twin Cities here, but we kind of focus on the broader Minnesota area. We've had people come from all over the state, especially in this new kind of virtual world. But we basically focus on education events, networking, professional growth. The networking has been a little tricky this year, as with everything. Our schedule is the third Tuesday of February, June, September, and December. We have these larger 2.5-hour blocks, which is our chapter meetings. Typically, it's a half-day event if we were in person. And then since we can't do our normal after hours, which is our happy hours, what we're doing for the time being is we're doing hour-long webinars. And you'll see those are the third Tuesdays in March, April, July, August, and November. The couple months we don't have any events is because we're supporting the local conferences such as Secure 360, and October has a couple different conferences, so we try not to interfere with those. With that, I have Kerry McMaster on from CSA Minnesota, and he can give a brief overview of CSA.
Hello, everyone. Again, my name is Kerry Manister, and I'm the president of the Minnesota local chapter. And just a brief overview about us. We were established in 2018. As of September this year, we became a nonprofit organization, so we're really excited about that. But our mission at the end of the day is to define and promote best cloud security practices. The other thing that we have a passion for is we believe in diversity in the security team at an enterprise. We feel that a diversified team brings a better security posture to an enterprise. The other thing that we are very, very passionate about is that there is a void or a shortage in the security industry. And so in 2021, we were going to be focusing on trying to fill that void and be part of the solution. The other thing that's coming up, we have a few events coming up. We actually have a celebrity. We have Brittany Kaiser coming speaking for us on January 28th. And Brittany Kaiser, she's in a Netflix documentary, The Great Hack. So if you haven't seen it, highly recommend you checking that out. The other thing about Brittany is that she, a little background about her, that she was the Cambridge Analytica whistleblower. So again, her Cambridge Analytica had a huge influence on our election, and then also on Brexit. And so again, I highly recommend her documentary, and she also has a book coming out called Targeted. And then in February, unfortunately, we don't have a date selected, but it'll be towards the end of February. We're going to have Melinda Rambleson talking about the application development and the changing landscape via delivering cloud. Also, if you want more information about us, please go to csamn.com/membership to learn more about our memberships. Any questions that you have, feel free to send me an email at info@csamn.org. Ryan, you just want to go to the next page? Again, just a brief overview about CSA. We are part of the Minnesota chapter here, but if you look at CSA globally, there's over 100,000 members. Globally, there's 100+ chapters. CSA was founded in 2009, and we have over 400 corporate members. But the one thing I really want to focus on and share with you is that we have over 35 active working groups. And what that means is that we are defining best security practice, and you can be a part of it by joining CSA. So for example, if you want to learn more about DevOps security, and if you want to be a part of developing the standards for the world for DevOps security, you could join a group within CSA. So again, all the research again is free. There's a lot of information out there. I just highly recommend it, that if anyone's interested in cloud, specifically cloud security, take a look at CSA, and any questions that you have, again, info@csamn.org. Thanks, Ryan. And thank you everyone for joining today.
Thanks, Gary. One other announcement I wanted to mention, as we have a partnership with UMSA, which puts on Secure 360. If you have not seen already, it is going to be a virtual conference this year, or this coming year. The keynotes are Alex Stamos and Shannon Polson. Deadline this week, if you're interested in speaking, is this Friday, so you can get those submitted on the website. And then also there's for the next 2 weeks, there's a very super early bird rate of $299. Normally the conference is quite a bit more than that. So if you're interested, I would highly suggest you get registered or submit for speaking as quickly as possible. Today we have 2 sponsors. We have Extra Hop and we have Axonius as the other, and they will both give a brief presentation during the break in between the speakers. So today's agenda, we'll get started here in a minute with Kevin Hakanson as our first speaker, and then we'll have a break for and the sponsors will give a brief presentation. And then it says speaker 2, but we actually have 2 speakers. We have Michael Ojala and Vanessa Grose as the co-speakers for the second session. And then after that, we'll do a brief wrap up and close. Before I turn things over to Kevin, if you have any questions during the presentations, please submit them via the questions panel in the GoToWebinar controls, and we will inject those as appropriate or hold them until the end of the talk if that works better. So with that, Kevin, I would like to give you presenter rights.
All right.
Once Kevin's ready, go for it.
Showing my screen. It looks like I can see it. Let's get started. Okay, so I'm Kevin Hakanson. This is my pretty picture right here on the title slide, although you won't have to look at that for long. I work at Ops Compass. I play a couple different roles. I'm our director of customer success, talking to a lot of our customers, but I really have a legacy as more of a principal cloud solutions architect. So I do a bunch of those tasks, and I'm going to come here to talk at our chapter meeting, who's in your cloud. Kind of the objectives, and we probably saw this from the outline, is we're gonna, it's this monitoring, security, and visibility are critical, right? So in this talk, we're gonna talk why about cloud is special. We're gonna talk about cloud APIs, including some things like the management plane, the control plane, the data plane. We've got this term we're gonna be using called cloud state monitoring. We're gonna talk about what is it, why is it important, who needs awareness of it, and more specifically, we're going to tell it through the use of some use cases, right? And it's not just an academic definitions; those are up front, but some actually examples of things that are interesting. So during the talk, if you have questions and you want to ask them, every time I hit one of these transition slides, I'm going to reach out. Carrie is going to be helping me, and then we'll go ahead and I'll kind of do questions at the end of each section if we want, as well as at the end of the presentation too. So when we see one of these colored slides come up, I'll look over, I'll see what kind of the open questions are, and then I will ask Carrie if there is any. So just to keep us on point, but still be able to be a little interactive during the sections. So when I talk about cloud, I really, I'm really thinking about the 3 main hyperscale cloud providers, AWS, Azure, and the Google Cloud Platform. And when you look at what the value drivers are for those cloud platforms, there's the obvious first 2, like cost and scalability, right? But what to me is almost the most interesting is the third one from this Forbes article. The fact that hyperscale cloud providers are interoperable with other systems via their cloud APIs. And that's what really lets them expand their capabilities and accelerate cloud adoption, because you have access to a lot of things you may not in other competing platforms. So it's somewhat hard to find some good definitions of things. So I have the next couple slides, and I'm gonna go through them just a little fast, but let you read them. Cloud Security Alliance themselves defines what the management plane is. You know, and they talk about this API interface to managing your cloud assets, right? And that's important. That's what also the consoles use. Google Cloud Platform ends up defining 3 planes, and I'll be interested from our Google friends on the call if they've got a better source reference to that. But they separate management plane from control plane from data plane, with kind of control plane being in the middle. So they reference these 3. Azure defines it into 2 categories. They talk about control plane, and this is the definitions that I'm most I won't say comfortable with, but I've heard the most, where your control plane manages your resources, but the data plane is the capabilities exposed by your instance of that resource type. Okay. So for purposes of some of these examples, this definition is the one I'm going to spend more time on, because it talks about in Azure, all requests for a control plane end up going to a common Azure URL, right? So there's globally a management.azure.com endpoint that those operations go to. But they call out the data plane operations because they're sent to an endpoint that's specific to your instance. They're not necessarily limited to REST APIs or a common endpoint. It might be, your database server. It might be specialized protocols. So data plane operations are different in that they're instance specific, which means the protocols are different. But control plane has a lot of consistency and commonality. The other items related to the kind of the APIs that come out of cloud providers aren't really the inbound APIs, but what I like to kind of call the outbound APIs. And for example, in Azure, any changes to subscriptions or resource groups will go ahead and emit events related to those changes, and they will drop it on something called the Azure Event Grid, right? And they'll end up creating events for changes. Azure doesn't create events for Git operations, but they do for things that are put, patch, post, delete, things that are sent to that same management endpoint. What data plane operations in Azure, you don't create events. So things that would go here in this example to your blob storage bucket. So it's kind of like I said, I usually refer to those as the outbound APIs. It is putting stuff in an event on a queue or a grid and you're getting it, but it's something important related to the APIs to monitor. Calling out too that Azure, with their common single control plane, it means they've designed it to be globally. It's across all regions. It's across all zones. It's engineered to be, not dependent on a single data center and not taken down for maintenance. So Microsoft believes they can engineer one control plane endpoint that'll work for everybody. And that's important when we compare it to AWS later. Now, AWS didn't have a good straight up definition of control plane and data plane like GCP or Azure did, but they kind of back into it when they talk about their events, especially the events that kind of go through CloudTrail. They talk about management events and refer to them as control plane operations, and they talk about data events known as data plane operations. So they use the same terms, but they don't come out and kind of define them. At least my Google foo couldn't find a reference in the documentation. So, and then lastly, AWS, as we know, loves their regions, right? And they think that region isolation is key to a lot of their resiliency. So the service endpoints for the control plane of services in AWS are region specific for the most part, right? Services like IAM does have a global endpoint, but everybody else is regional, right? And during the AWS keynotes in the last couple of weeks, they kind of stated that's why the problems in US East 1 didn't expand beyond the rest of the regions. But it's just kind of a difference in architecture on how the control plane is managed. All right. So from the end of this first section, right, kind of quickly going through a couple of those definitions, I wanted to just highlight from this and recap. There's really was no common definition for management plane, control plane, and data plane. There's a lot of similar concepts, right? Of all of them, data plane was probably the most common across of them. And just pointing out that there's significant differences in both the architecture and infrastructure related to these cloud APIs across the hyperscale cloud providers. I didn't touch on the Google structure there. I had a hard time finding a explicit reference, but everything I could find, some of their kind of Google front door services, they're more of a global, kind of a global deployment model as well. They've got a lot of solid architecture from many years related to handling those requests. So, all right. Time for the first question break. I'm going to assume that no one had questions about boring definitions because they're not all that interesting. So Carrie, if you do hear something, just pop in during these from the audio section. All right, now we're going to get into this term that we talked about, cloud state monitoring. All right. Now, of course, every good definition should go to a very credible primary source like Wikipedia. And if I really had my streaming stuff, I would insert the laugh track here because that was funny. But it is an interesting points from the Wikipedia definition that were important just to define state for everybody. Realizing that state is often used for computer programs that operate sequentially on streams of data, right? And the information about the previous data received is stored and used to affect the processing of the current data, right? Oftentimes we hear this called the stateful protocol, right? And that data that's carried over is called the state. So when I'm talking about state, I'm thinking about state in terms of this, in terms of what you might use for a stateful protocol. So therefore, cloud state monitoring would create the cloud resource changes, as a stream of data, right? And intelligently monitor both the current data as well as changes from the previous data or state. And kind of taking that stateful protocol approach, tying into those outbound APIs, those event grids that come out of the cloud providers. We're going to have a bunch of use cases going on, but just some easy examples to think about this. You're monitoring current data for security risk configurations. I left port 22 open, but I monitor changes in data for things like configuration drift. So the state is probably more like the second one in this list because it's looking at the previous and the current state at the same time. Another kind of definition, and this particular definition came from Microsoft. Although this four-letter term is another one of those Gartner terms. I don't think it's got its own quadrant yet, and who knows what's going to happen to it. But the term of cloud security posture management comes up, and it's defined at the point that Microsoft defined it then as new functions, right? It does things that were impossible or difficult or manual before the cloud, before these cloud APIs and these events were universally available to us. And cloud security posture management is an emerging discipline, right? And it's probably going to disrupt, the norms of the security organization, right? It's going to have new capabilities. It's going to shift responsibilities among roles. It's going to create roles. So, this is the hype, right? On like almost everything that comes out with an acronym, there's something really cool and hype about it. But I do believe that the availability of these APIs and the data of these APIs really does give us something that we didn't have kind of pre-cloud. That's kind of why cloud is different. All right. So this slide and the next slide are the only two slides where you will see the explicit Ops Compass logo. Just because I wanted to use that as kind of a reference because that is the that is the space that I'm in. That's the things that I think about every day. So this diagram here, and you can go ahead and Google OWASP Cyber Defense Matrix, is based on a model that kind of maps the kind of CIS access types along the bottom and the NIST cybersecurity framework security functions along the top. And the idea is you want to be monitoring stuff. You want to have a proactive security posture, and you don't necessarily, want to have a reactive, to security events first. But realizing that both are important for a security program. All right. So when you think about identifying, protecting, and detecting, understanding about your state monitoring is about that protect and about that detect, and trying to figure out if the thing that changed was related to a security event, or if the thing that changed was related to just something that you need some normal architectural awareness for. Okay. So the first three sections of the first three security functions of the NIST cybersecurity framework, the important things to understand from here. So, and on the bottom of this slide, you see that you want to use technology more on the left side, and you want to save your human time and your people to work on the more complicated problems. So that's kind of the one slide with some pretty colors, and the other one that I made myself, which is a lot less pretty but still has colors, is just this picture. And again, not meant to be totally read through. This is actually a very simplified view of kind of cloud architectures, but it sets up the reason kind of to talk about the different components of an API structure, right? You'll see everything on the left that's coming in, whether it's SDKs or APIs or infrastructure as code or the portals, all comes in over APIs to just some different kind of management or control plane services. You'll see that there's policy enforcement points, your AWS IAM, or your config rules retrospectively, or Azure Policy, Azure RBAC, both of which log events, either CloudTrail or Activity Log. They send stuff to CloudWatch events or Event Grid. So if you're going to have a system that does cloud state monitoring, and that's represented by the Ops Compass logo in the corner, you not only need to listen to the events for changes, but you need to reach in to those control plane APIs to be able to get at that kind of that metadata about your cloud resources. So as we go through the next set of slides that have use cases, I'm going to refer back to some of the components in these boxes. So this would be a time if you wanted to screenshot this, you could like kind of refer back to it when I'm talking, or we can just, you can look at the deck later. So just wanted to point out that's the point of this slide, is to realize how things are wired together. Okay, time for any questions so far?
At the moment, there's nothing, no questions so far.
All right, cool. Is everyone awake still? That's probably the next question, right? Or should this be said? Who needs caffeine? Right? Okay, we'll move on to the next slide. Figure I would stop. All right, when I think about a best practice kind of cloud operations team, or if I think about a cloud center of excellence, I've taken this diagram from the Microsoft Cloud Adoption Framework, and I've thrown in some other personas in there. So in their progression from a cloud MVP to a fully cloud kind of optimized, they like this is their ultimate solution, right? You're focusing on self-service and you have some centralized governance and automation and security, but you have independent teams that can deploy stuff to cloud. So it's a big harmony of everyone working together. Like I said, I threw a couple other kind of sets of personas on there. I threw DevOps teams, even though I know a DevOps is a culture, not a product or a team, right? It's still a touch word that people understand. I threw in architects, I threw in risk and compliance separate from security, just to kind of set the stage for how I view in the organizations that I've been in or have been working with, how things are kind of structured across the team. And I'm assuming a lot of you on the call probably feel aligned with kind of one or maybe a couple of these groups. But when I talk with these groups, and I've just kind of called these personas, I've just kind of abstracted, or genericized what they might say. I've talked to development teams, right? And they believe in automation, and that's the key to success. But they say, well, doesn't my CI/CD pipeline control all these cloud resource changes? They're all in on this pipeline, and they think that's in control, and we're going to learn why that might not be true coming up. Your architect oftentimes is concerned about the visibility into all the resources and policies. They want to see some consistency. They want to know what's out there. Right? Your cloud security practitioners oftentimes set some standards, and they want to know if you've drifted from those baselines, your security and identity baselines. Not only did we set things up to secure, but is it still that way? Have we drifted from it? What do we need to change? And your risk and compliance teams, they want to be able to intelligently track that compliance, right? When things are constantly changing. The developers want to constantly change it. The compliance teams often, maybe we're used to doing a report every year or every quarter, and now things are constantly changing, and they'd like to be able to access that evidence or that information as it's happening. So you kind of got some kind of key personas that all are interested in kind of the state of the cloud or cloud state monitoring. So when I ask the question, who is making changes, right? And it's going to be you as the customer, right? And I use some of the same terminology that's kind of used by the cloud vendors, the workload teams, and those are the ones, either building product or deploying kind of third-party product. You've got your platform teams. Oftentimes they're called your landing zone teams, or sometimes your CCOE's got a team. They're all kind of building your subscriptions and your access control. They're enhancing automation all the time in those landing zone areas. And if you've got your security teams, and they're updating policies. They're turning on kind of new and important security controls in the environment. So you've got at least 3 groups of people making changes in your cloud environment. And then you've got cloud providers making changes, right? They might be adding new services, adding new features to existing cloud native services. Maybe some of those features aren't going to enhance security. You also have cloud providers having a lot of hosted open source software. So they're updating the versions of that software. So there is continuous change in the environment that maybe didn't come from the CI/CD pipeline, and it's potentially creating risk. Not necessarily, right? But it's something to be aware of. And when I talk about the shared responsibility model, this has kind of been around for a while. Every one of the hyperscale cloud providers has a version of it. CIS also has a version of it. This is what they all look like. And you'll see they all split the difference between, well, almost all of them split the difference between infrastructure as a service and platform as a service. They all have layers on what the cloud provider is responsible for versus what you as the customer is responsible for. But in the end, every single one of them puts data or content or information and that accountability at the top of the stack, which is like the customer is always responsible for. So, and interestingly, that's oftentimes monitored from the data plane as well as access to it from the control plane. So that's kind of the shared responsibility model. I wanted to just put this eye chart of the multiple versions just to show everybody kind of agrees that there's responsibility to go around, and it isn't just kind of one team. So, okay. Going to get into one of our first examples here. And it's going to be the Azure Storage account. All right. So an Azure Storage account, or the kind of blob storage in Azure, similar to S3 object storage, right? One of the first services that was out there. It contains kind of data objects, blobs, files, queues, tables, disks, right? Pretty common service for cloud providers, right? The storage resource provider, right? And in Azure, services are known as resource providers inside the Azure control plane, right? So you'll see the word resource provider, and you can just think that's an Azure service. That's kind of an implementation, right? It lets you manage this account programmatically, right? And every API requires, the request to be versioned. So for an example, I just pasted this nicely formatted version of kind of a REST API into the management plane for a storage account. And we're going to be looking at kind of on the next slide something related to this. But you'll see that it's very nicely formatted, what subscription, what resource group inside the subscription. It's going to highlight that it's the Microsoft storage provider. It's going to give the name of a storage account, and then there's going to be that API version is going to be kind of the last parameter there. Now, don't try and read the code on this slide, right? The point of this is that green colorization that you're going to see, right? Because the highlights actually include specific values for a resource that I created in the Azure console. So what I did was I called an older version of the API, the one from November 2018, to kind of simulate if I had created that storage account back then. And then I called the June 2019 version of that API. And you will see that 4 new security features had been added to Azure that I now would have the ability to enable. Whether I wanted to allow public access for my blobs, okay, or disallow it, whether I want to use a specific encryption key type, if I want to turn up the minimum TLS version, and if I want to do some private endpoint connections, okay? So the cloud provider made a change here. They added functionality. That functionality you could either read about in the updated documentation, or you could actually, detecting the change in the state of this cloud resource, you could realize that there's some more functionality there that maybe you would want to investigate. Okay, so that type of change is extremely interesting to me because nobody made a change in a pipeline. Nobody went in the console and made a change, but yet a change now exists that is beneficial to your organization's security state. So.
Kevin, there's a question out there for you.
Oh.
Okay. The question is, when Ops Compass creates the latest data as the state, then when is that updated for trending purposes?
The word trending is, maybe not there. Ops Compass itself does a very similar monitoring to what I did, what I captured here. And this is just, I did some cut and paste into Visual Studio Code and did a compare here. Ops Compass is a feature, and I didn't want to put a bunch of screenshots from our product in here. We have a very similar piece of functionality that not only highlights us the differences, but we actually zoom in on specific paths down the JSON that we find is important. So we do some trending. So in our tool, for example, you would see a lot of these resources have changed. You'd see some drift in there, you'd get alerted on it, and you'd be able to zoom in on specific things. So that's how we have solved that type of problem in our kind of cloud state monitoring, cloud security posture management. So as I hope that answers that. Was that in the chat that you saw that? Or was that actually in the questions?
Correct, in the chat.
Okay. 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 Any other questions, or was that just the one? I didn't see it. Okay. Let's just remind ourselves about TLS, right? There's been a couple of versions, 1.0, 1.1, 1.2, all right? Prior to that change in kind of June, it might have actually been in April of 2019. They only allowed 1.0. The change that Azure made was, hey, we are going to now enable the future versions, but we're going to still allow clients to connect with 1.0 because we don't want to, they're backward compatible. They don't want to break stuff for you, but they want to give you the ability to make a change. So therefore, not only is this property not set by default, but it doesn't even return a value unless you set it, okay? And if the value happens to be set as null, then it actually defaults to the original version of TLS 1.0, okay? And if you do want to set it, it requires an API call into that April 2019 or later version of kind of the API, okay? So it's there, it's not turned on by default. You have to explicitly turn it on, which is good because they don't, Azure doesn't want to break you, but you also then can't take advantage of it. So that's kind of just an interesting, the reason it's important to monitor, because it's like, hey, it might not even have showed up, okay? So that's fun. Now, in this slide, I'm going to, again, twist the definition of infrastructure as code to meet my needs, right? Just like I twisted the definition of DevOps. So I think most of you, and then correct me if anyone has got a different question on this, but most of you think about infrastructure as code as those kind of JSON-based templates that you create, that you put in your pipeline. It defines how you want something created. You send it to some sort of deployment engine, and it goes and it creates the resource. So in the example on the left, you'll see the only like 5 fields that you need to define to create a storage account, right? You run it through deployment manager, it creates a thing. Now, when you look on the right, you'll see that not only are those 5 fields valued, but there's a lot of other fields with a lot of other default values that have been turned on, okay? Some of these are items you weren't in control over, like the endpoints, which are based on the name. Some of them do have some default values. So when you compare the left to the right, the question that I ask customers is, should you consider the JSON-based output from your REST APIs also to be infrastructure as code, right? And it's not something that you want to get and check into source control necessarily like the same way you would do for one of the templates you deploy, but it is something that you could pull out new versions and do that same type of difference that we did 2 slides ago. Right? So in that way, I refer to it that way, even though it's maybe not the most proper definition of it. The other thing I like to point out on this slide is, where's our friend minimum TLS version, right? It just did not get valued. Again, it was that tech note that we had earlier. If it wasn't explicitly stated, it's not going to be valued. It's going to come back, either be missing, be null. It's going to be TLS 1.0. So there's other things that are kind of hard to catch related to this. So, but this was kind of, like I said, I feel like a very interesting mapping, talking about infrastructure as code versus the source of truth, which is the cloud providers' cloud APIs, and getting the state of that data. All right, next slide, we're going to talk about Amazon RDS. And so if you read this slide, you would think that RDS will automatically do upgrades based on this comment, right? If you want to automatically upgrade, turn on auto minor version updates. And in this example on the screen, it's turned on, it's true. This should be Boolean simple, right? But if you look closer at that, you look at the version of MySQL 5.7.28, and you look at that timestamp that's in there, which is the last restorable time, which means that we must be past that time when this JSON was captured. And then you look over to the versions of MySQL that were both generally available and then supported on RDS. And there's always a lag too between the versions that are, when they came out and when they're supported. You will see that 5.7.28 was basically from February, and there had been at least 3 versions of MySQL, 2 supported by RDS since then. So if you're like the little, floating head icon there in the middle, like me, you're probably confused, wondering, why is this? I have this on, it isn't upgraded. So the answer is, you call this API, and you get what the current database engine versions are, right? And it's another cloud API that you need to know about. And I asked about MySQL 5.7.28 in this API call, and I got back a list, and neither of 5.7.30 nor 5.7.31 were auto upgrade eligible. They're set at false. Okay? So there are newer versions that you can manually upgrade to that aren't supported by that auto upgrade flag. Okay? So when you think about this API call, this is really another kind of state of the cloud or a cloud configuration that you need to monitor to understand the full state of kind of what your RDS version exposure is. All right. So I was confused. So I kept digging into the documentation, and then I found this very fun quote. Right. For some RDS versions, in some regions, okay, one minor version is designated as the automatic upgrade version. Oh, and by the way, RDS doesn't automatically set newer released minor versions as the automatic upgrade version. Okay, so that was a little disappointing to know that they did that. What was the most disappointing to me was a couple of the key regions in AWS don't have any auto upgrade versions pegged for any release of MySQL. Okay, no upgrade support at all. And the regions that do have it none of them support the latest version, and there's differences in the versions that are supported across regions that do support the upgrade. So here is where the AWS strategy of kind of region isolation plays out in kind of an inconsistent experience for a developer, right? Meaning that maybe this field is not the field you want to set. You just as a team want to be in charge of your own versions. You still maybe want to monitor what the current versions are so you know what you can manually upgrade, but don't necessarily trust some of the settings that you can. So this is, again, a reason to manage state, right? And when I recap on these previous slides, we're really, you think it's Boolean simple, right? If an engine version changed and that was on, probably an AWS change, maybe, right? The absence of a change when new versions are available, like the problem we had, something you want to monitor, right? You want to monitor that set of available versions and the region consistency problem. So that just kind of simple example has got like 5 different, I feel, pieces of information that are important just to understand the whole picture. All right, we're going to flow through, talk about.
Hey, Ryan,
RBAC.
just real quick, I'm just doing a time check. How are we looking on time, Ryan?
I believe we have until 2:05. Yep. So we still got 16 minutes.
Yep, sounds good. I have 35 minutes and counting since I started. So I was assuming then 15 it was done. That kind of lines up. So, all right, thanks for the time check. Now, Azure RBAC, right? This again, I'm not going to read through this whole picture. The thing I love about Azure, right, is look how consistent and well defined that is, right? You got these security principles on top. You have role definitions. You have scopes where you can apply that role, and then you have this role assignment. So the grant access by assigning security principle, a role, a scope, very well defined, as well as the assignment kind of flow down a hierarchy. If you don't have the action, you don't get it. If it, things are blocked, it's like very nice and very structured, right? I really like their security model, but we'll see a caveat coming up soon. So now, what's interesting then about the way that Azure does things is they have got this concept known as an extension resource, right? So an extension resource is a resource. As you can see here, there's JSON representations of it. There's an API to get it, but it's a resource that's applied to another resource to extend that capabilities, okay? So by monitoring the resource you don't get it, you actually have to monitor the extension resources tied to that as well, okay? Now, if you think about, if you come from an AWS kind of space, think about resource-based policies, because they're often attached to a resource. Think of that as similar to extension resources, right? And if you think about an AWS custom role, that would be really similar to your own role definition in Azure RBAC, right? So today, also these role definitions, they tie to the subscription, and they just kind of like an IAM role kind of ties to your account. So just kind of think of that model. It's another piece of resource that's in place. Okay, but when things get interesting is the consistency hope that I had earlier. Yeah, I forgot about things like legacy, where some of your classic subscriptions had these other two special roles that don't show up in as an Azure role. They're a special Azure AD role, right? And then there's this little enablement thing where you can elevate your access. And I've kind of put it in the red box in the screen, where you can go ahead and, as a global admin in the Azure Active Directory, you can give yourself full access to your entire Azure subscription, okay? And it's not one of the roles that's attached to one of your resources. It's not the role attached to your root management group. It's a special, it's a special switch. And I equate that to that break glass AWS root account that you might have, right? You don't really want to use it, but when you need it, you really need it because things are serious, right? So it's something you need to monitor. If somebody uses this, you want to monitor it because they have now given themselves elevated access, and it's not a state that you want to consistently be in. You want to turn it off when you're done. Okay? So fun things to monitor. The other item that was on the slide of things to monitor, there's something called Azure Policy, right? And then here's some of the Microsoft language. It helps you enforce things at scale. What's interesting about it is it compares the properties of the resource that's being created from that cloud API against some business rules you have, right? And it's different than RBAC, is that it's not worried about the operations that are happening, but it's worried about the properties of the resource, okay? And the combination of policy and RBAC are the things that give you your kind of full scope of control in Azure. And a kind of a specific example that I use about it, first, I remind people about resource tags, right? And resource tags we'll use in an upcoming use case as well. They're labels. You have this user-defined keys and values. You attach them to cloud resources as metadata. They help you organize things. You can use them for IT-aligned operations, like what's your environment or what's the workload. You can use them for business-aligned requirements like accounting or cost, allocation, ownership, criticality. And with the caveat that there's some services that select tags, they don't support tag and create, right? There's other limitations, right? Tags are an important management technique in the cloud providers and something that's easily enabled by the cloud APIs. So an example of an Azure policy that has the effect that you might not want it to is these tag policies below, right? And if you remember, you process requests, right, to create or update resources before they're handed to the appropriate resource provider. So there's this interceptor layer where it can change or block the API based on the rules, business rules in Azure Policy. So here's an example of enforcing tagging rules, right, by applying the needed tags before deployment. But if you look at a couple of these examples, and if you thought, hey, I'm this DevOps team, I've set some things in my infrastructure as code, it's possible now for one of those cloud operations teams to go ahead and modify that request. Maybe they're adding tags, replacing tags. Maybe they came up with a brand new required tag and now are denying your request because it doesn't have the tag or the tag and a specific set of values. So a pipeline that was working fine could now just break, or it could output something different than it thought. And in some technologies like Terraform, tags are part of the state, and you'll end up, if tags are changed on you when you read the current state and try and sync it up, it might be different. So these are kind of a policy can intercept and make changes on you, and it's something you gotta make sure that you're kind of monitoring the policies that go in place, so you know that it's affecting your resources. Okay, coming through the last use case until we're done. Any more questions?
No more questions. Hey, Carrie, if you don't already, can you mute your phone? It's causing a little bit of feedback.
All right. Now, last example, talking about AWS IM. Okay, and they refer to their stuff as policy 2, which is a totally different policy. Here's an eye chart we're not going to read, right? Just realizing that the complexity of the evaluation logic from AWS goes through a number of steps that are a bunch of different policies, whether they're coming from the organization, the resource, some permission boundaries, session policies, identity policies. There's multiple places that you can take the same policy language and apply it into AWS. All need to be monitored. All can affect what happens as far as the decision. Okay. Now, just like Azure has got built-in roles, AWS has got managed policies, right? Standalone policies administered by AWS, right? Which means that it's got its own identifier, its own Amazon resource name, and that includes the policy name on it. And it's got an identifier there that's kind of unique, and you can figure it out, right? And you can't, it's managed, right? Because it's managed, you can't change the permissions defined in it, right? But AWS occasionally updates these permissions in a managed policy. So that's kind of, again, a change that is being made not by you, but by the cloud provider, okay? And interesting, these policies, if you dig into them, even though they are quote unquote least privilege on the actions that they allowed, usually they're resource star, right? So they're not least privileged on the resources they apply to, right? So that's kind of just for those of us that have dug into AWS IM, something that's interesting to learn. Okay, now here's another feature that we do have natively in Ops Compass, but what I'm showing here on this screen is kind of one of my favorite open source projects related to the same problem. So there is a person that is running this every kind of 4 hours, although they did up it to every hour during reInvent because there are so many announcements, therefore so many new managed policy changes. They grab all the managed policies, they see if there's any changes, they basically check them into GitHub, and you can see the differences. And you can either get alerted straight from the GitHub repository, or you can follow this account on Twitter, and you can actually see all the changes that come in. And this is interesting because, there's changes that happen and then they're undone, or that they change quickly, and it kind of makes you wonder what kind of control is on these changes. A specific one that I like to pull up is this security audit one. And I do this because this is one you often grant to your cloud security posture management providers. You don't have the ability to set the version, but when this change happened in September, these are the new set of permissions that you have just granted. Now, it is managed by AWS. It probably does make sense, but again, it's a change that you didn't make. You didn't maybe review the audit. It happened, and now if you've granted that to an external person, like a vendor, that's the new permissions they get. So again, important to monitor. Kind of coming to the end here, the last kind of subsection with AWS IM is when you look at how they define their access levels, they've got listing, reading, writing of permissions. Those are kind of a little less interesting for this example, so I've grayed them out. But they like to highlight two things. They like to highlight permissions management, right? The ability to grant or modify resource permissions, with a special tip in the documentation that you should monitor this, right? It's super important to monitor. And then they talk about tagging, right? And it's just only change the state of resource tags, right? Only that. And we saw earlier that tags are used for a lot of things, including cost reporting and ownership and a lot of metadata things. So it kind of makes sense on this surface that tagging is kind of its own special thing, right? But when you dive into what AWS has enabled for attribute-based access control, right? That's an authorization strategy that uses the attribute permissions or the tag permissions in AWS to grant you access. So they will have you match a principals tag to a resource tag, similar to that code that's on the screen now, as a way to kind of make it easier to grant access to resources in bulk. So if you're tagged with a certain project ID and the resource is tagged with a certain project ID and this policy is in place, you get access to all those resources, okay? So it's a nice way to kind of scale up that permissions. You're not listing out explicit resources. You're not trying to do prefix-based condition matching. You're doing tag-based matching, all right? So kind of an interesting way to do some things. But again, you need to monitor it, right? And if you look at our previous access levels, we have now elevated tagging to the same level as permissions management. So if you in your organization thought, well, tagging isn't as important, I can have other people do it, and then you have some developers turn on attribute-based access control, realizing now that you have a kind of a change in state where you've got now certain policies with conditions that include those tag attributes that you want to monitor. So again, monitor, there's CloudWatch events that are created. You can create event rules on them. And then you can either do automatic workflows using Lambda functions, human workflows as part of auditing, any number of types of things you can do, right? So, but again, it's important, again, it's everything is interrelated. So the state of everything together becomes important to monitor. Closing thought slide, and then we'll see if there's any last questions in my remaining like minute and a half. Cloud APIs, you know, one of the most powerful value drivers. Resources can be changed by any number of actors. Monitor the state of these resources for both security and other misconfigurations. And then kind of the key point, a change in state of that cloud resource can provide you information related to your security posture. So, all right, thank you, everybody. That is my contact information. That's my LinkedIn. Got probably a couple of minutes for questions if there are some additional ones.
Just wait to see if any pop in here.
Or applause. You know, and this is where I had my Stream Deck ready to do my own applause, but I wasn't smart enough to route the audio on my Mac. So I tried, but I had to give up Googling it because stupid. I love the Mac, but boy, are they hostile to installing stuff in your system that can intercept audio and video for some reason.
Yep, I don't see any more questions. Just a lot of thank yous and well done.
Okay.
So yeah, I think we are good.
Okay. All right. I'll go ahead and stop sharing there. Thanks, everyone.
Yep. Thank you very much, Kevin. This is a great talk. And with that, I believe Jeff from ExtraHop is up next here. Jeff, you should have presenter controls now when you see that. You there, Jeff? All right, maybe Jeff's not there. John, are you by chance ready? We can flip you guys around.
Sure, I'm ready to go.
All right, so we'll do Exonius first. So we'll have John, you should have presenter controls. I think everyone should be administratively muted, but can everyone just double check if they're muted? We're getting some feedback and I can't quite figure out where it's coming from.
Hey guys, I'm here now. Can you hear me now? This is Jeff from ExtraHop.
Oh, hey Jeff.
Hey, sorry about that. A GoToWebinar pop-up was on a different screen, so got it all sorted. So I think I'm ready to roll now.
All right, John, you cool? I'll flip back to Jeff then and let him go.
That works for me.
Okay. Sorry about the confusion. All right, Jeff, now you should have controls.
Okay, perfect. So give me just a second here. You guys should be able to see the screen that I'm sharing.
Yep.
Perfect. Okay, so apologize for the confusion there. My name is Jeff Deininger. I'm a principal cloud SE from ExtraHop, based in Seattle, where ExtraHop is located. And during this short, just couple of minutes presentation during the break, I really just got one message to convey to the audience here, which is use packets to find cloud threats. It's way more effective, and I would also add way more fun than treading water in the data lake. So why do I say this, and what do I mean by this? So I want to start with this phenomenon of attacker dwell time. And the reason is that it's in some ways an indictment of our profession, right, as security practitioners, that late in 2020, dwell time is still measured in months, that the average time to identify and contain a breach, the average, right, is still 279 days. And that it's kind of a coin toss as to whether when we're breached, we figure this out on our own, or if law enforcement or some other outside entity notifies us. And so I think this actually points to the reality that attackers have a structural advantage over defenders in this game. And I call this notion attacker-defender asymmetry. And so what do I mean by asymmetry? But it's the notion that attackers launch millions of arrows, only one of them has to land. And the consequences of failure for attackers, not landing the rest of the arrows is actually very low. Automated attack frameworks, script kiddies don't even have to know what they're doing to kind of play around with the Metasploit framework and lob these attacks in our direction. Meanwhile, for the defenders, the consequences of missing an arrow are extremely high. Defenders have to block all the arrows, because we know that from our dwell time stats, that if we miss one, by and large, attackers will have the run of the place, right? They'll be able to move laterally, conduct reconnaissance, etc., and be able to go undetected for weeks or months. And so defenders really have the deck kind of stacked against them, because not only do they have to block all these arrows, but they have to do it while managing an irreducible attack surface. And we just learned from Kevin that security is not as Boolean simple as we would like it to be, right? So we have to know when the Azure Storage Resource Provider adds the minimum TLS version, now, and that we can now upgrade our security and reduce our attack surface, and so on. And so one of the conclusions that organizations are arriving at is to assume breach. And this is really the InfoSec corollary to the DevOps conclusion of assume outage. And so from a NIST cybersecurity framework perspective, what's needed is to add some attention and some investment to the detect and respond pillars of the framework. Organizations are fairly, have the first two, identify, protect, and then the last, the recover pillar, fairly well understood. But the detection and response space is uniquely different from, say, asset management or reducing your attack surface. And so I've got these three takeaways for you to cover in the last 3 minutes of my presentation here. And the first is that detection and response is its own unique problem space, requiring its own investment areas, its own tooling. And that in cloud in particular, detection and response is not possible using first-party capabilities, that you actually have to look to third-party marketplace vendors in order to implement this capability. And then lastly, not all third-party marketplace solutions for network detection and response are created equal. So a couple of subpoints here. Detection and response is really the other side of the coin from reducing your attack surface. Regardless of how well or you are managing and staying on top of your cloud security posture and understand the configs of your cloud infrastructure and resources, you still need to understand, are you being attacked right now? Are any of the CVEs that are leveraged by the FireEye red team tools being used against you right now, right? If a particular technique was being used, say zero logon, for instance, how would you know? And if you did know, if you were able to know, that now means that you're empowered to stop it, right? You can actually stop an attack in flight versus waiting for post-compromise cleanup. But to do this, you need some kind of an early warning system. And so cloud service provider native tools, the reality is that most of them aren't even trying to solve this problem, which may come as a surprise, right? There are first-party offerings for cloud security workload protection, for posture management, et cetera, for baseline analyzers, best practice analyzers, and so on. But if you look at the one or two that are trying to do some behavioral detection and response, they're largely looking at logs as their data source. And the majority of attack behavior against both the management plane and the data plane turns out to be unloggable. And so this presents a problem for defenders. But then the other challenge for building a detection and response capability with cloud, say Amazon or Azure native tools, is you end up with this kind of Lego blocks paradigm rather than having a turnkey solution. So it's largely left to the end user to figure out how to kind of wire the different components together. Next, and this is a big one, is that cloud providers don't offer packet analyzers. This is why they've introduced things like Google Packet Mirroring or Amazon VPC Traffic Mirroring to smooth the path from getting packets from workloads into third-party marketplace solutions. And then the last is, I'm actually gonna skip this one because I've only got a couple of seconds left. Last, for network detection and response solutions, they're not all created equal. So if you want to evaluate doing some packet analysis to protect your cloud workloads, to understand your attack surface, you should look at a couple of criteria in order to sort through the competitors in that product category to understand which ones are going to be the best. And I would suggest that the ones here on the screen are the ones that you focus on, including the ability to decrypt TLS and TLS 1.3 conversations in order to do the full transaction and content analysis required for meaningful behavioral detection. So with that, I hope that was mostly coherent, and appreciate your time. Thanks a lot.
Thanks, Jeff. John, I will get you going here. So next up we have John from Axonius.
All right. You should be able to see my screen, correct?
Not yet.
Not yet. Let's see. Show main screen. Let's just try just a window. Is that working?
Nothing yet.
It shows I'm sharing the screen. I'm going to turn it off and try it again one more time. It says sharing the screen. Is it sharing now? Still nothing?
No.
Okay.
Hi, John, this is Anna. Sorry, I actually had the same issue earlier today with the webinar. So I'm not sure if there's something going on with GoToWebinar, but I could also try to share it on my end if you want.
Yeah, if you have you already shared it with you. So if you'd like, we can try making Anna the presenter.
Let me just pull it up 1 second.
Right. Perfect. There it is. Wonderful.
Great.
We can see it, Anna. Thank you so much. I appreciate that.
Just let me know when to go to the next slide.
Will do. There's some builds as well, so you'll kind of just click through things as I'm talking. So we'll go to this first one, and I'll do this as fast as possible. I've been asked to share a little bit about Exonius and asset management in between 5 and 7 minutes. So hopefully it won't be like drinking from a fire hose, and we'll go at a pretty good cadence here. Here at Exonius, we focus specifically on asset management for cybersecurity. And the reason why we make that caveat is because we're not really looking to depot every mouse and keyboard. What we build for our customers is a granular, credible, comprehensive, self-updating inventory of their devices and users, whether it's on-prem, bare metal, virtualized, in the cloud, or remote. And we do this so that our customers can get a full visibility across their environment so that they can most adequately protect and secure it. And on that same path, it allows them to easily meet things like the CIS Top 20, specifically 1 and 2, as well as other more advanced frameworks like a high trust if you're in the healthcare industry. But when I talk to most customers, they usually find themselves, next slide, Anna, a little bit like this CISO. And I'm sure none of you can relate to this. And I'm not exactly sure the situation that made them ask this question, but I'm assuming it has something to do around Windows hosts. And we share this a little tongue-in-cheek. We know it's snarky, but the truth of the matter is it resonates because it's funny until you have to do it. And for us, we really wanted to ask, why is asset management so difficult? Next slide. And to really figure this out, we went back in time to when asset management wasn't so difficult. And back in the day, we had very flat, homogeneous networks. Pretty much you had Dell and IBM hardware plugged directly into Cisco networks, routers, and switches. Then as technology changes, we see things like new operating systems and management consoles. Then we add things next build like BYOD, mobile devices, next-gen AV. And then we add things like cloud compute and server farms, and we continue to grow that with vulnerability scanners as well as IoT. We'll go back a slide, and multi-factor authentication, user identity solutions, things like that. And I'm going to stay on this slide for a while, Anna. When we look at this, this diversity of tool sets creates a lot of complexity within environments. And for us, we see this as both the problem and the solution. Because when we look at all these different tools, whether they're the actual devices themselves, the virtual infrastructure, the cloud infrastructure, the agents, the scanners, all these different tool sets have great, unique, rich data on your users and devices. And theoretically, the totality of all of these tools together, your technology stack is the totality of your environment. The problem is that all of these different tools house that rich, unique data in their own databases and problematically in their own schemas, and getting that into a centralized database that's understandable, comprehensible, and actionable, that's the crux of the issue. And when everything's in disparate sources like this, it makes it hard to answer some pretty typical questions. Next slide. And I break down the questions I see most into 3 different categories. And the first is around agents. And the question I hear the most is, next bullet, is my agent everywhere it should be? Or more accurately, where is it not installed? The next one that I see a lot is it checking in? Where do I have devices that are live? They've been seen anywhere in my environment in the last 7 days, but they haven't checked in over 30 days to their management console, things like that. Another one we see a lot is what agent version is it on? Is it up to date with my current policies? Some other things I see around cloud. The first one really we see a lot is, what instances were not scanned by my VA tool, with devices being ephemeral in the cloud and spinning up and down all the time. It's hard to know what's out there. What instances have public-facing IP addresses, or even as Kevin mentioned, we're looking for 422. How do we find that easily across all of my cloud environments, Azure, GCP, AWS, all at once? And then also, how does my environment compare to the CIS benchmarks frameworks? I heard Kevin mention that earlier as well. The other set I see is around unmanaged devices. Specifically, what unmanaged devices are on my networks? The next, who manufactured those devices? How can I start to go in to understand what they are? And then lastly, how long have they been here? These are questions that I see all the time, people trying to ask, and it takes a lot of time to build this out. And this is where Exonius comes in. Next slide. So our approach is broken down into 3 main functions. And the first thing we do for our customers is to get a credible, comprehensive, auto-updating and self-maintaining asset inventory. And we do this primarily via API calls. We talked a little bit about all these tool sets being cloud-based and being interoperable. We're able to pull from all these different solutions to build this inventory multiple times a day. The next thing we do is once that information, all that metadata is in one place, we index it so that we can ask questions of the data and surface gaps. This little screenshot right here, it's hard to see, but essentially it's asking the question, what's checked into Active Directory, as well as is in ESXi, so it's virtualized and it doesn't have CrowdStrike installed. And these questions can be very simple like this, or they can be extremely complex and granular. And we do this so we can find things that are not in the ideal state. And then the last thing we do is help you get things back into policy, back into that ideal state with automation. Essentially what we do is we take that query, we save it, run it on a scheduled basis, look for output, and then take action, from things like send an email or a Slack message to maybe create an incident in your favorite ticketing system, ServiceNow, Jira, or even update devices in ServiceNow or your CMDB. There's lots of things we can do here, but essentially we want to get the data, ask questions of the data, and then take action. My last slide here is going to be pretty quick. How do we do it? It's a virtual appliance that you can have deployed in your own infrastructure or up in your private cloud. It's 100% agentless. So going back to things like APIs, we're connecting to the management consoles of your tool sets. We're pulling back the metadata they have on your users and devices. Because we're maintaining these adapters, as we call them, we know the schemas, we put them all into a single data model so that we can systematically deduplicate, deconflict, correlate them, and aggregate them multiple times a day to give you the most accurate inventory across your environment. And with over 300 pre-built integrations, it can be up and running extremely quickly. So that is Exonius in a nutshell. Very quick and fast, but I hope that was educational on how we are helping customers focus on asset management specifically for cybersecurity.
Thanks, John.
My pleasure.
All right. We can, Michael, Vanessa, are you guys okay if we start at 2:30?
Yeah, that's fine. If we want to call it a 5-minute bio break for everybody, I think that's appropriate.
Yep. So I'll take a 5-minute break, everyone.
If you can switch the presenter rights to me, and I'll just have the intro slide queued up, okay?
Yep, perfect.
Thank you.
All right, so everyone, yeah, you got about 5-6 minutes here, and then we'll get started with our second presentation right at 2:30.
If anyone is still hanging around, just let me know if you can see my screen.
Yep, I can see it.
Yeah, it's coming through great, Michael.
All right, perfect. See everybody in 5. Time check, we've got about 2 minutes and then we'll get started. In the interim period, if anyone wants to solve the riddle, it is, why aren't koalas actually bears?
I can hardly wait to hear the answer to the riddle, Michael. I'm waiting with bated breath. I think your headset's acting up a little. I'm not getting audio coming through from you.
Shows you got yourself muted, Michael.
Okay, it's just a button. Okay.
There we go.
Vanessa and I have a long-running problem with hardware, and I like that this was a software solution. Classic. So everybody can see the presentation, right? I'll wait for y'all to give me the heads up, and then Vanessa, just let me know, and I'll just get started. Okay.
Okay, but seriously though, what with the koalas? What?
Oh,
Why
well,
people need to know the answer?
they're not bears because they do not meet the qualifications.
Oh, Michael. So friends, we are so glad to be here with you from Google Cloud today. We've got an intro and security overview planned. I'm going to give you a brief view of our agenda for this time that we have here together this afternoon. We want to give you a little bit of an introduction to Google Cloud, a little bit about our philosophical approach and our history, and then a high-level overview of how the cloud is structured, the different layers of how we approach security. We'll show a demo of an application running on Google Cloud so that you can see how all of that infrastructure and security comes to life in the context of something real. So that's where we're headed for the next 45 minutes or so. There should be a fair amount of time for you to ask a bunch of questions at the end. So that's what we're going to do. And by way of introduction then, so we've got two speakers here today. There's me. I am Vanessa Grose. I work at Google Cloud. I am a head of customer engineering in the Pacific Northwest, which means that I manage a team of customer engineers who have this really fun job of going out and working with customers and helping them figure out how they can use Google Cloud to do cool stuff for their business. It's just a really fun place to work. I'm also a Minnesota girl in my heart. So I live in Seattle now, but I was born in Minnesota. I grew up in Rochester. I went to school in the Twin Cities, and I just love Minnesota. It makes my heart happy to be here hanging out with you all today. So that is me.
All right, so on my side, my name is Michael. I worked for Google for about 3 years. Before that, I spent a decade in the gaming spaces, and I've also worked at Microsoft and Intel in other capacities. Real pleasure to be here. I'm super excited about this. So before we did stuff, we wanted to do a fun thing. So if anybody can open a browser, it can work on a phone, on your computer, use the code. Vanessa would really like to understand dog data.
Inquiring minds want to know. Yeah, I mean, these are important questions we're asking. Yes.
So while you're doing that, let me give you just sort of a high level overview about Google itself, right? So I think organizations have typically looked at public clouds for cost savings to augment private data center capacity, stuff like that. And Google's perspective is security is first. Everything else follows after that. And so that is a big part of the presentation that we want to do today. So I'm going to switch my my screen here to see if we've got some votes that have come up.
Says the question's not open for voting. Also, Michael, your microphone, it just sounds like a little bit fuzzy or something. I'm not sure.
All right, I can try and move it closer to my talk hole. Is it better if it's right there?
It's a little bit better.
Okay. It says voting is closed. Vanessa, I don't know. You made this thing. Maybe you don't want anyone's advice and you just want to decide your own favorite.
I have deep personal feelings about it, maybe, is what you're saying. I can't. How do I make you? It doesn't want to open.
It's all right. We can move forward, certainly. I just feel like I needed to know. I had an opinion, but I don't want my own anecdotal opinion to drive this. It's inappropriate.
Well, since the questions are misbehaving, I think we should probably go ahead and talk some about the history of Google Cloud. Let's do that. So what is Google Cloud all about? Where did we come from? When Google started out in the late 90s, there was really no cloud provider for us to invest with to build out the infrastructure that was necessary to power Google search. So we had to do it ourselves. And imagine the scale that's necessary to power something like Google search. You can't run a search engine that processes billions of queries every day, returning results in milliseconds. You can't do that unless you have state-of-the-art innovation around infrastructure, networking, data management, and so on. So we had to figure out how to do it. We went through this real pain of building out a global infrastructure footprint with the necessary compute, network, storage. We learned what it would take to keep the data from literally billions of users safe and secure. And we created the process and the hardware and the software, all innovations that were going to be necessary to make that work. And it turns out that we were pretty good at that. So on the next chart, you'll see that we actually have nine applications that are consumer facing that have over 1 billion users. Over 1 billion users, like that is just incredible, incredible scale. And it blows my mind to think about that. So if I'm seeing, we can advance one chart, Michael, that'd be awesome. So over this, last 20 years or so, Google started doing all of this. We were building the cloud that we needed to power our own business. And as we passed into the early 2000s, it became clear that the rest of the world was suffering from these same types of problems that we were having. So about 10 years in, around 2008 or so, we were like, you know what? We can help with this problem. And at Google, we have this thing where we are innately really helpful people. We really want to be helpful and useful. And so we looked at this problem space and we were like, you know what? we can make our internal cloud that we have been using, we can make that available to people outside of Google, and we can let them leverage all of that infrastructure and all of the lessons and everything that we have learned to make their lives easier. And in fact, with Google Cloud, which this is not true across all cloud providers, the platform and the tools and the services and everything that you get access to as a consumer of Google Cloud, it really is the same. It's exactly what we use to run our mission critical applications, which I really, really love. So on the next page, as we think about technological innovation and this journey that we've been on as Google Cloud, I wanted to highlight a little bit of the recognition that we have received according to industry analysts. And this has really evolved really quite rapidly over the last couple of years. So thinking about things like, Gartner, Magic Quadrants, and Forrester Waves, if you look at where we were back in 2016 with these, 3 leadership positions, and now that that pace of improvement and growth. So now here in 2020, we've got 28 leadership positions across those Gartner and Forrester analyses, which is just phenomenal. What an amazing pace of improvement and growth. And it speaks highly to us and our strategic vision, the maturity of our offerings in the marketplace, and really the great things that our customers say about us. And the 2 that I love, especially for this audience here today, are around cloud native security, or IaaS, like platform security, and data security, where we are the top leaders actually in both of those Forrester Waves, and we were evaluated top among all the people who were analyzed in those for our strategy and direction, which is awesome. That's us. That's us at Google Cloud, really, really deeply invested in our technological platforms and bringing strong innovation and strong strategy to market. So what actually makes Google Cloud different? I'm going to say that this boils down to 3 things, and those 3 things are innovation, empathy, and openness. And you might be like Vanessa, what do you mean innovation, empathy, and openness? Those sound like cultural values. Those don't really sound like technology platform concepts. But here's the thing. They are actually both. They're both things. So innovation, right? So, we're Google, so we're known for innovations around all, data and analytics and AI/ML and security, all sorts of things. And when we see problems, we want to solve them. When we see something that's going wrong in the universe, we want to make it better. So, think about managing global scale virtualized infrastructure. And we've got millions of containers that have to run and make all of this stuff work. And that's a lot. That is a lot of pieces that have to spin up and down, and you have to manage, and you have to know what's going on. And that is a very complex problem to solve. And so, we think about that and we're like, okay, well, let's build a management framework to make that happen. Let's build an orchestration layer that's going to make that possible to manage. And so we do, and I especially love this one because the code name for it is Borg, which makes my little Star Trek nerd heart super happy to think about all of these containers coming in to a collective and being assimilated. It's perfect. And so we take that and we develop that internally to solve a problem, and then it becomes something like a Kubernetes framework, which everyone is familiar with, and it's open sourced, and the rest of the world can come and build and innovate on top of that along with us. And we say a lot in and these innovations, by the way, are not just around technology, they're also around process and people concepts, like site reliability engineering for us and the procedures around that, really, really innovative. And customers will say, they don't maybe come to us always because they want to buy stuff from Google. They kind of come to us because they want to be Google. And a lot of that is around this innovation space and how to become the best innovative version of themselves, and how to really drive that kind of transformative thinking in their own businesses. So innovation. Next was empathy. So what do I mean when I say that? And When we talk about an empathy-based infrastructure culture, the idea is this: most people, they don't want to spend like their nights and weekends fighting fires and dealing with production outages. People want to do their work. They want to go home at the end of the day, and we want to make things that are easy to use and robust and reliable, and to develop practices and procedures that make all of that possible, right? Your devs, they're not pushing code out into production because they want it to go down, right? They want it to work. Your ops people aren't releasing new infrastructure as code assets into the universe because they want it to crash. We want it to work. And the things that we try to do as a platform provider are to just make all of that easy, right? How can we make it easy? How can we, again, be helpful? And one of the offerings that we have inside of Google Cloud that I think is particularly relevant to this audience that does that is this thing called the Security Command Center, where it's literally like you click a box and it turns itself on, and it's just baked in, and you get automatic centralized reporting on your configuration, helps you maintain compliance, helps you discover misconfigurations and vulnerabilities, helps you identify threats, and it's just easy. It's easy to use, and we believe really strongly in that empathetic culture of making things helpful and useful and easy to consume. And that translates into how we work internally as a business as well. So the third one then, around openness. Openness and transparency are other values that are so fundamental to us inside of Google. And you can certainly think of this technological openness in terms of open source, or so, Kubernetes or TensorFlow, all these big name, open source projects that were born here at Google and that we put out into the universe to drive stronger technological innovation. But beyond just open source, which is great and important and we believe in deeply, there's also this idea of open architectures. And like every customer that I talk to is really interested in this and thinking about open cloud architectures. How can I build these hybrid multi-cloud systems that help me avoid vendor lock-in, control my costs, give me the flexibility to really do what I need to do that's going to make the most sense for my business? And that's what we want. We want innovation, we want empathy, we want openness. That absolutely comes through in the technological platforms that we put out into the universe, but it's also really, really central to just who we are as Google and how we operate. So as we get ready to transition over into—
I had a couple of data points that I wanted to add to what you said.
Oh, yeah, do it.
Because data, we do data and stuff.
We do that.
The last,
yeah.
the last publicly available data that we shared was it's from years ago, but Google will launch, I believe, over 5,000 containers for our own services every hour. So that is simply the scale that we operate on. And I think the way that we view it is very similar to what you just said, in the sense that our perspective is your software should run on our systems. And if our systems can't support your software, well, that's our problem, not yours.
I love that.
And the other one, with respect to security, because I'm a security nerd, Google has absorbed the largest DDoS attacks that have been publicly made available. And the story from 2017 with respect to Krebs and the denial of service attack that was launched against Krebs on security, the Google Cloud team that was connected with Krebs, their commentary was super simple. It was, if we take on the Krebs domain, can they take down google.com? And then someone was like, well, if that's a possibility, we have larger problems. So we do this. So I'm super proud to continue this conversation. This is fascinating. The way you did that was perfect lineup. Thank you very much.
Well, Michael, then let us continue with the conversation. So I know you're going to walk us through a lot more of a view around the infrastructure, how the network comes together, all of the security components that we have, and then moving on into showing some real life Google Cloud in action. So please take it away.
Cool, thank you very much. So just again, for everyone's edification, I did spend a number of years breaking DRM systems and securing large systems. So I'm super passionate about this. At a super high level, Google comes from the perspective of security first, everything follows. The infrastructure, the security, the networking that was created to originally support Google search itself, and the spikes and changes in demand that made a standard data center opportunity an option were relevant. So that's how this all began, as Vanessa stated. If you want to back up from that, I think, and not anecdotally speaking, I think that the Google mission, as it moves forward, is literally to create the best AI in the world, and everything else is predicated on that is the ultimate goal. Whatever that becomes. Right now we're at like 5% of that opportunity, 10% maybe. But all of the infrastructure has to exist, and it has to be secure in order to create this next generation thing that we are definitely working on. So we can't do that if we're not honest with you. We can't do that if it's not cost effective. And if that's what we need, that's what our customers need, and that's what we want to provide to everybody. So let's get started with that. We're going to skip the thing. Okay. So thanks, Vanessa. I see you're picking it up. So at a super high level, these are just words, but Google has the world's largest software-defined network. There is nothing comparable. It's because we had to create it in secret for 10 years before we understood that public cloud would be a thing. And as Vanessa said, once we crawled out of our nerd holes, we were like, oh, we can help other people? Well, sure, we'll totally do that. But so we built a massive amount of this before we knew it would help other people. And so now you've seen, I think, a $5 billion infrastructure investment over the past few years to really build this out. So just a super high level, this is what Google looks like if you're going to transmit data from place to place. You have your data center somewhere in, we're going to call it North Virginia today, and there's a direct connection from your co-location facility or from your actual hardware directly to that place, that point of presence, to that region, wherever. And that goes down through cables we actually lay under the ocean. It's a massive project that we're quite proud of. The repeaters that couple them together is a topic that takes like a half an hour just to talk about because we're super keen on this. The point I want to make about this is from the moment that something enters our network from the region on one side and ends up on the region on the other side, it's connected functionally to an ISP on one side or a carrier network on the other, right? And so it's a direct connection to wherever your end user is, and information on Google Cloud never transmits across the open internet. It's just something we will not do as for reasons and stuff. So this is a good map of the actual points of presence, the network, and the dedicated interconnects. So these represent where data centers exist. They represent where you can have a direct tie-in from your networking equipment to ours, and nothing transmit the open internet. And here is all of the thousands of little edge nodes everywhere around the world where their point is to pipe back into this centralized network. And there's a bunch of really cool statistics that show if say like a soccer game is won, in Central Europe, and so like the network in Central Europe is being massively swarmed, specifically in Spain because they're better than everybody else. Fight me. No, it's fine. Just kidding. My brother lives in Germany. So that amount of traffic on that network means that if a packet from, say, Portugal needs to go to Italy, it's actually faster to route it around the world because of the software-defined network that Google built for this. And that this is a massive part of the Google magic that exists, because the network is software defined. It's not hardware based, and it's very impressive. So a lot of organizations look at Google Cloud as a risk because moving data can be seen as something insecure. And so what I'm trying to show you here is how you input data into that network. We have a bunch of different mechanisms. You can literally take a rack, plug it in to your on-premise infrastructure, copy data, unplug the rack, and ship it to us. There's so many options as it relates to risk. So we think the opposite. We think that moving your data to cloud is actually a safer option because we do have more eyes on this than most. And because of our security and risk posture, we can work with you to make sure that you end up secure. And I think that that's something that we're very proud of. So again, in terms of transparency, we are very clear about how we operate. Rule number one, your data belongs to you. We cannot access that. As an example, I have a contractor status for one of the customers that I work with. And so I can log in as you know, so-and-so at mycustomer.com to a Google Cloud Console. Even through that, I can't access all of the data that that customer has available because of the structure that we create. And so as a Google employee, I would never have access to any of that. And even as a contractor, I only have access to the certain aspects that I'm allowed to, and we think that this is appropriate. We do not sell customer data to third parties, period, end of story. We will not do that. We would, it's an abhorrent thing, and I hate that I have to say that. We don't use data for advertising. I know Google, the fuel for the Google Cloud rocket ship is revenue from the Alphabet organization. We can all acknowledge that, but we do not provide data to make that better because rule number one, your data is yours, it's not ours. So data is encrypted in transit. It's encrypted at rest. We think encryption is important because of 2003 and things. There is not an opportunity to create non-encrypted data. We do that. It's a default option. You don't turn it off. It just is what it is. And we do that for security mechanisms and the layers of security that we create, which I'll talk here in just a second. There is, again, very clear, there is no backdoor into Google. We don't do that at all. Nope, no secret government access. If we found out about it, turns out that was in 2003, and then we made a whole bunch of changes. And it wasn't because we said they could do that, it's because somebody made a choice and did that on their own. So, so we're very clear. There is no backdoor access, we don't sell data. Our audits are very clear, and we will share that. So those are that's the heavy slide. Okay, now we'll get fun. So these are the layers. Google absolutely operates like this, and I have actually been to one of our data centers. So it's a very cool thing that it's like a movie set, how complicated everything is there. Like the people who design the main central command center for a Google data center aren't allowed in it once it goes active. Like there's an entire like changing of the guard. Nobody can do that. So that is just one example. So like this slide I could talk about for a very long time, but the point is actually what I would really like to do is move to here. This is a better example. So when I'm talking about the in-depth security model that we use, every organization is going to have a different threat perspective and a different opportunity to actually protect themselves, and you can get more nuanced as you go. You know, we are going to encrypt all your data at rest, in transit, whatever. If you want it encrypted with a special key, perhaps we can do that. If you want it encrypted perhaps with a key that only you own, we can do that. And so it's really it's a judgment call on where on that line is appropriate for your organization. And I've worked with organizations who are super savvy with containerization, and other organizations who they have dependencies on, you know, Win32 attributes that have to have a, you know, single threaded opportunity, and so they can't do containers or whatever. So like you have to find where here makes sense, but we're going to support you on the security side. Protection is one side, control is the other, and then compliance is our third sort of pillar. Control really represents the IT side. How do you monitor? How do you detect? How do you make appropriate changes? Whether it's tying it in with Active Directory, whether it's creating one-off serverless sort of probes, agents to scan systems, there's a lot of solutions. But the control is really meant for the organization to bolster its own opportunities. And then compliance is really about satisfying the needs and requirements for financial services, banking, security, whatever your industry is, medical, stuff like that. So this is my favorite part. So Google is unique because we are one of the largest server manufacturers in the world. Not many people know that, but it's a true thing. It's a totally true thing. So our full stack is custom built. The Titan chips, which is the next slide actually, the Titan chip inside our servers is explicitly included to reduce our attack surface. So this chip inside our server is on version 3. If Google updates a data center and we remove version 1, like a server with version 1 of this chip, we have to destroy it because it is generations more evolved than what you can buy on the open market. And that is a massive differentiator for the Google Cloud and the Google network, because the chip Titan will validate every little component of the boot sequence to ensure that that machine is not compromised and that the software running on it is the valid software as proposed by the customer. We're on now version 3 of the Titan chip. Version 4 is in a pre-release state right now, but it is again, this is one of those things that we could talk for another half an hour about. I'm very, very proud of the Titan chip. This is our encryption strategy. When data comes in, this is the default standard, and obviously you can, as we talked about before, you can add your own unique keys. But data, when it comes in, is chunked out, separated out. Each chunk has its own encryption key associated with it, and those are blasted out across servers everywhere, right? So like if super hardcore spy guy came into a data center and dropped down through the roof and pulled out like a hard drive, they would only get one like section of the data, and that section of the data would be encrypted, right? So that is how that works. And then that encrypted data is propagated more so that you have the availability. So then, okay, this is the best part. The encryption key itself for each chunk is then encrypted again, and then is wrapped in another system so that the encryption key that encrypted your data is also encrypted and still propagated out throughout the system. And it's all mathematically savvy. And I like to say that we roll it in Pete, but that's only relevant for Northern European people, I guess. Anyway, so at a high level, encryption by default, totally normal thing. We won't change that because that's awesome. You can have your own keys, and then you can bring your own keys, where literally all Google is doing is bringing encrypted data and putting it in a storage bucket, and then you do what you want with it because we have no access to it. Oh, yeah. This is funny though. 100% of Google Cloud customers have encrypted data because we covered that. It's a default. So Spectre and Meltdown. If we're not up to date with Spectre and Meltdown, I need to just do a small update here. Okay, so the Google Cloud Zero teams are a bunch of world-class security experts who probe for problems and stuff. The last time I saw publicly available data was in 2013, and there were 600 people on that team. It's a pretty impressive organization. Spectre and Meltdown problems are related to what's called speculative execution. So it's like a black magic inside of a CPU that says, oh, I think that a user is going to want to do this thing, and it's going to speculate that and then proactively cache that data so that when a user does run it, it happens very fast, which is a very fancy trick. But the problem was that pre-caching mechanism could be absorbed by attackers, and that's not okay. Google runs our entire infrastructure and have for a very long time with something that's called Live Migrate. What Live Migrate is, it's the same thing that we use on a Chromebook, actually. So like on a Chromebook, if you use them, and you should, it literally has 2 operating systems at the same time on the on the machine. And if something happens, it literally is like, oh, I got my update. Cool. I'm just going to turn this one on, turn the other one off, and update my other one. And so that same concept of being able to flip an operating system immediately for whatever update happened happens in our servers too. So when Spectre and Meltdown were exposed by the Google Cloud Zero teams, we had been able to update every server that Google owns overnight, and everyone else had to apply a patch and handle downtime. And it's a main point of not just the fact that we are cool, hacker hunters and stuff, but that the way our infrastructure is built is designed to support these massive changes quickly, even at a very deep level. If you're a Google Cloud customer, you didn't even notice Spectre and Meltdown. Other customers, it was just different. So I know I get into a nerd hole. So let's keep ahead of threats. Vanessa, do you want to talk about the Chronicle piece here? I feel like this is a good spot for it. Or do you want me to dive into that? Okay, so Google was, as has been noted, the recipient of several nation-state attacks. Chronicle, as an organization, was created after one of them, and the main point of Chronicle was to backtrace what happened, and this is the name of the product, Backtrace, one of the many products. The data that comes from Chronicle now exists back within GCP as a product level, and we expose some of that threat intelligence that is garnered through these solutions as APIs to our customers. And as a result, you can tie in your existing infrastructure and say, hey, if it pipes through, it's coming from IP address, whatever. If that is a known bad actor through this other system, you have that availability through an API. And it's really about the honesty that Vanessa was talking about before. If we have information that we feel like we should provide to people, we're going to do that. You get the opportunity to make whatever choices you want, but it would be abhorrent for us to shield you from something that can benefit you. Oh my gosh, my numbers were way bad. We have invested $47 billion over the last 5 years. When I joined 3 years ago, it was $5 billion over the last 3 years. So I think that this is expanding massively. I need to do a time check here. How much time do we have left?
We have about 15 minutes.
All right, great. So let's move through control. I think that this is really important because it's really about the collaboration between yourself and another organization. I cut my teeth in places that ran their own servers and did everything on their own, and we were quite proud of that. Transitioning to Google Cloud takes so much risk away, and you have to balance the risk you're taking away versus what you want to create and make those hard choices. But the customer responsibility and the cloud provider responsibility is always going to be balanced, a lot like the previous speakers have spoken about today. And we just feel like we need to be honest about what are the options and how can we help. We are going to provide templates, solutions, open conversations, and obviously anecdotal bad jokes. That's the thing we do. So, data loss prevention. This is one of the small features amongst many that we're really, really proud of, where incoming data through a pipeline, a data pipeline, can have PII, and that's inappropriate to pass to other systems or whatever. This is an API that literally, in real time, as it comes in streaming, handles that. Completely removes that information, and for a particular user who should have access to that, like it's the the customer support engineer who's going to do the refund or whatever. That particular user can have the access rights to have this information, but by default, it all gets masked for everybody as it comes in. And that that individual who would have the permission to read that can, again, be like the exact same Active Directory or whatever solution that you're using on premise anyway. So it's a super sweet, fast solution that if you're thinking about Google as, oh, we're trying to create the AI of the future and just make all these things simple, these are one of those things that we would just do. Also, if you want to get super deep, the protein folding work that Alphabet is working on is also a good reference point. So, oh, I was going to take that slide out. So let's talk about partners. Before that, though, let's just talk about that slide I skipped. Confidential computing is a concept that Google released this year that is fantastically forward. It literally means that the in-memory data that you are using for your applications is still encrypted. So most people think of, I have data, I put it in a server and it's encrypted. And then I take that encrypted data and I bring it into my application and then I decrypt it and do stuff. What this is literally the encrypted data comes in the app, your app does stuff with encrypted data. So if you were going to, take a snapshot of the active memory at that moment in time when the application was pulling in all of this super secret data, even that active memory could not be read because it's all encrypted at runtime. And it's a massive technology shift. And the slide that I skipped was really looking really forward. That's how Google views the future of complex and sensitive data, much like you would use HTTPS and not HTTP if you were going to log into your bank. And encrypting active memory data is something that is something that we're only making available this year, and it's very next generation. So it's hard for me to not talk about that more. So let's talk about partners. We have so many partner opportunities that these capabilities are really designed to ease a transition into Google Cloud and also balance what the existing infrastructure and policy and structure, the existing policy and structures that exist for your organization. These should be the organizations that you are working with already if you have a strong security posture. And so we are marrying our product offerings with the opportunities that they provide too. It's tough. We only have a limited amount of time. I want to make sure that Vanessa can do this nice wrap up here. I'm a huge nerd. I'm a big security nerd, and I'll talk about this all day. So thank you very much for the opportunity, everybody. Please let me know all your big hard questions, and I'll answer that.
Yeah, can you tell we're a little excited? Oh dear. But honestly, Michael, around that partner ecosystem, like that is huge for us. And I know, the first few years of Google Cloud and people were like really skeptical, like, oh, do these guys really know what they're doing? Are they really enterprise ready? And the definitive answer to that is yes. Yes, we are. And the partner ecosystem is a huge part of that. I think the investments that we have made with people like me and Michael being now available to work with enterprise customers and drive these situations, it's amazing the level of investment in this space. So exciting. So what could you do next if you have questions about Google Cloud or you'd like to dig into it anymore? Yes, Michael and I work in the Google Cloud sales team, but we don't sell to any of you. But if you have a desire to engage more, there are a ton of resources available where you can go out and do hands-on labs or work through certification processes, and where there are people inside of Google who can help you do that. And it's not me and it's not Michael, but we can help you find who those people are if you are interested in that. So please use me as a resource. I'm so happy for that. Find me on LinkedIn, connect with me. I would love to be your friend. If you have a question, ask it, and I will help you find the right person or the right resource, because this is fun stuff to explore, and we want you to be successful, and we want you to have a good time and find the right digital transformation path that's going to make sense for you.
I'm her friend on LinkedIn. It was very successful. I do have a quick demo, Vanessa. If there's still time, I could show this right quick.
That is a good question. Ryan and friends, how are you feeling? Should we try to show a quick demo, or should we do questions, or what?
I see there's 2 questions in there for you. I sent your way, Vanessa. And then, yeah, I think I only need about 5 minutes, or probably just a couple minutes to wrap up. So we could go about another 10 minutes if you.
Oh, let's do the questions first then, and I can show my little thing later. That's fine.
Yeah, I feel obligated to call out that I got a lovely Go Royals call out from Chris, which absolutely, Bethel University. Yes, awesome, great place to get educated in Minnesota. And then the technical question. There was one about what if we have regulations to keep data like within the United States? So you've got some data residency requirement. Yeah. Can Google facilitate that? Absolutely.
Data residency is a thing that we have to support for the European Union, obviously. So to keep it in the United States is obviously equally easy to do. Yeah, I have a lot of other examples, but the answer is yes.
And you can see about, like, you can read about it too. If you just like Google Cloud data residency, and it tells you all the cool ways to do it.
And you can using the command center that you were talking about, Vanessa, you can easily see even probes coming from other places, even though they can't access stuff. It's all straightforward.
And then I'm seeing an encryption question also from Colin, and it asks, is that leveraging homomorphic encryption? So I'm not exactly sure where that came from.
We do. So we do offer a homomorphic encryption solution. That would be, we should set up a second session to talk that through. But Vanessa, Vadim and I worked with one of our customers specifically with homomorphic encryption. So nice. we should have that conversation.
So sounds like yes. And if that's something that Colin, you or anybody wants to dig into, you can reach out.
And then we should do a sync, Vanessa, me, Vadim, and whoever is asking the question, for sure.
Cool. So I think, Ryan, those are the ones that I have seen come through, questions in the chat so far.
Yep, that's everything that's in here so far.
Okay.
Oh, yeah, so I just got a question here. It says, why are all the stadiums so hot in 2020? That doesn't make sense. I think it's because all the fans left.
Oh, Michael.
I did that. All right. So let me show you some stuff and things, code and stuff. Can you see my IDE as it pops up?
Yeah.
Okay, so you can see this window, you can see this. What you're seeing here in PowerShell, this is a server that's running just here locally. It's my Firebase server. This code, I will send you guys all how this all began. But what I wanted to show was these two parts side by side. So this is the actual website that I'm running. For clarity, I did make this morning. And Vanessa knows that, and she thinks it's very funny. Because I had another one that was like real estate and stuff, but I was hungry and I felt like this would be better. So this website is a responsive design, so obviously it would work on a browser, it would work on a phone. I'm running it locally, but moving to Firebase hosting is very straightforward. Here's what's so cool. This is a very straightforward website with a database that's powering it. And I can go in here and I can say, oh, I have no ratings. So I've added a method to add some mock ratings, and then, a database will get updated, and then great. Look, now I have ratings. Neat. Okay, so that's automation. I love automation. So The problem is, just as an example, the problem is that this place in Austin, the Spot drive-through, server, where are you at? Spinning. All right, I'm just going to restart it then. There we go. So here's my place. We got our updates, great. We got our feedback, cool. So, but the problem is we made a mistake. The Spot drive-through, here's the database. We spelled this wrong. Oh no. People are going to be like Googling this place and it's spelled wrong. It's supposed to be the spigot. I don't know. I'm just trying to think of another word. Spigot. I don't know how to spell that, but it's the spigot drive-through. So right now, all I'm going to do is update the database. And so we're clear. All of this infrastructure is sitting on top of every secure mechanism that we've just talked about. And the entire point of this is to remove all of that simple functionality and focus on allowing other people to create better products for themselves. So I'm going to press update here. Did you see it on the other site? It's updated automatically. I never had to refresh or anything. This is critical for Firebase because it's a cross-platform, Windows, Mac, mobile, everybody. And if your cell phone has dropped out of reception for a moment and, the app was in the background and then it came back into reception, this is what would have happened behind the scenes. You literally turn your phone back on, the UI has updated because it all happens in the background, but you're not having to pull that in your application. It comes from Google's, magic tech. But it's stuff that's like really, really simple like that where, let's put this back to the Spot. The Spot. That's a cooler name. I like that. The Spot. You should go there in Austin. Bam, done. Immediately. And that would affect every user using it in a mobile perspective, using a PC, everyone across the board, that gets updated immediately like that. And Firebase itself has analytics opportunities, ad opportunities, A/B testing, all of this stuff. And from our perspective, what we're trying to do is present a platform where you can use all this stuff in the easiest way to create a better product than we could have ever thought of on our own. So it's a real pleasure to share like these opportunities, and we just want to answer more questions and help you. Thank you very much for the time. I have a thank you slide. It goes like this. It says thank you, right, like that.
Perfect. Well, thank you both. I want to thank all the speakers today, as well as CSA for doing the joint meeting.
Thank you very much, CSA.
And I think we'll reach out and see if we can do a more extended demo or something another time here with you folks. So with that, I think we will wrap up a couple minutes early, and thank you everyone for their time today.
Thank you, everyone.
Real pleasure. For reference, my email address is ojala@google.com.